Alright, Mr. Claxon's Algebra 2 or Algebra 1 class. Today we were talking about different mistakes that can be made when calculating compound interest. You take example number 30, that was from the problems we had last night. That's a with respect to t is equal to the principal multiplied by the quantity, 1 plus the rate divided by the number of times that the interest is compounded annually. Raise that to n, which is the number of times compounded annually, times the number of years. Alright, for this particular example, it would be a big mistake to multiply 1,000 times 1 and add 0.06 raised to the, really that's the 40th power, or 2 times 20 power. That would be incorrect. That's missing the parentheses there. That is missing those parentheses that it so desperately needs there. It needs the order of operations to function correctly. So you would get the wrong answer if you didn't put parentheses in. If you have the TI-83 Plus calculator, well, you can stop and read that. Read the incorrect way. In fact, try to enter it into your calculator the incorrect way if you have a TI-83 Plus. This is real hard to do if you have, by the way, a TI-84 Plus. If you have a calculator that looks like this, it's really tough to enter it in incorrectly. So, looking at this with the TI-83 Plus, you really have to be aware that you must have parentheses. You must have parentheses around that exponent. And really what I want you to do, I just want you to multiply 2 times 20. I want you to go ahead and multiply that 2 times 20 to get 40. Okay? Just multiply that 2 times 20 to get 40. And that should solve any mental mistake that you're going to make. Now I'll let you stop and read this. If you would like to know how to use a basic function calculator, being one that looks like this. If you turn your iPhone sideways, you can pick up this screen, and you could use this to complete your homework, right? If your calculator isn't charged, or if you forget your calculator, maybe you're stuck in a snowdrift somewhere, and you just want to do some calculating compound interest. You don't have access to the internet. All right, so pause and read that if you would like to learn how to calculate compounded interest, with a basic function calculator. What I want to focus on in this video is that rule of 72. I ended so abruptly today. This is what we copied down in class, and then I kind of went over it really quick before class ended. We've got the rule of 72, which you can read. The rule of 72 is just a way to estimate. It's a way to estimate how long it's going to take our money to double at a certain interest rate, right? So if our interest rate is 3%, notice how I divide by the whole number 3. Okay, I'm just pulling the 3 out of that percent. I'm not dividing it by 0.03. I'm dividing it by 3. So 72 divided by 3, that's about 24 years. That's an estimate. I would say about, okay, or about if you're from Canada, 24 years. Okay, 24 years. So using logarithms, we will get to this at some point. In order to complete this by using logarithms, I've laid it out step by step. I'm really not going to explain it other than by saying the formula that I use to set it up. This right here is the compound interest formula. The compound interest formula, a with respect to t, is equal to the principal, which is the starting value, the amount you have to invest, multiplied by the quantity, 1 plus r divided by n, okay, and that's n quantity, raise that to the n times t. So, and that 1 plus just represents growth. This right here represents growth, okay, so your money is growing, and then the rate divided by the number of times compounded annually. Well, this rule of 72 only works with what we call simple interest, okay, simple interest, simple. And it's simple because it's only compounded annually. And you probably remember this from middle school, the simple interest formula. So we kind of refine this compounded interest formula into the amount is equal to the initial amount, you might remember this from 6.1, multiplied by, well, what else? The multiplier, right? Raised to the nth power. Okay, so in this case, I would have the principal multiplied by 1.03, that represents a growth of 3%, growth, again, growth of 3%, 3% is a decimal, raised to the n, right? The reason why I divide by p on each side is because that will cause my p's to cancel out, right? Why did I put 2p on the left side? Well, if I'm doubling whatever I started with, what's double p? Double p is 2p, right? So 2p divided by p is 2. Okay, you're left with 2 equals 1.03 raised to the nth power. We would use definition of a log, you don't know it yet, to get this bottom logarithmic equation. Moving to the next slide, we use what we call a change of base formula, or I use a change of base. And then that change of base is what you're going to enter into your calculator to calculate the exact value when we get to class on Monday. So all that you needed to do tonight was to create a table. I'm going to show you how to do that in your calculator. So in your calculator, and by the way, you know what? I would like to show you how to enter logs into your calculator. So I'm going to enter in that log of 2 divided by the log of 1.03. So let me go ahead and do that for you. There's the log. And that's really saying log base 10. Log base 10 of 2 divided by the log base 10 of 1.03. Okay? We're going to get 23.449772225 years. So really, that is my end value. My end value, the exact value is 23, and then I'm just going to say about 23.45. Well, how does that compare to our estimate? You'll notice that it's pretty close to our estimate. You know, if we want to know how long it's going to take to double, when you're dealing with that many years, you know, what's a half a year, you know? So you now know how to enter in logs into your calculator. I should have ended the parenthesis there, but it really didn't matter. Looking at the y equals, if you go into y equals, you can see here I have 72 divided by x. That's going to give me my rule of 72 estimate. That's y1. Down here in the red, y2, probably make it easier if I extend the screen. In y2, this is going to give me my exact, right? And if you wanted to enter that in, you could enter that into your calculator. We are going to do it at the start of class on Monday. Maybe you want to get ahead of the game, right? So I'm going to now go to my table. Second graph gets me to my table. You can see it has an error at 0 years. And you might be able to think about why there's an error at 0 years. Obviously, because at 0 years, your money's not going to double, right? So in addition to that, that would leave a 0 in the denominator of the blue equation. So obviously, it would take 72 years, okay, at 1% interest, which is really exactly it'd be 69.661 years. Okay, so looking down the table, what you had to do is you had to create this all the way through 20. So I have 0 to 10 there. You could start at 11 and enter in 11, enter, and then 12, enter. Okay, and what you're going to start seeing is that the rule of 72 is not such a great estimate for the first few 1, 2, 3, 4 1, 2, 3, and 4 years. It's not the greatest, and then as we get toward 20%, it's not the greatest. Then we'll talk about that. But this is how you can make that table. You would just copy that on a separate sheet of paper. If you really want to be advanced, you could use Microsoft Excel spreadsheet, or you could just use a Google Sheet. You could use a Google Sheet by going to Google, and you would log in. You'd want to log in using your school username and password, and click on Sheets. Okay, once you clicked on Sheets, you're going to have an option. You can choose a blank sheet. Okay, and I've kind of already started what I want you to do here. You use a blank sheet. I've entered in some information here. The interest as a percent, notice how I just wanted the number of the percent. The interest rate as a decimal, I would enter in 0. I already have this formatted. I've right-clicked on this, okay? Or I've clicked on that, and I've clicked Format, and I want to format that into a percent, right? So if I enter in, 1%, that's really 0.001. okay, and then 2%, 3%, so on and so forth. The logarithmic, well, or logarithm, which I've misspelled, logarithm doubling time, it can be found. What I would do here is I would hit an equal sign, put an equals in there, and then I want to log. I can just type in log, and I'm taking the log of 2, and I want to divide that, okay, forward slash there, and I want to divide that by this column, and I need to, or I'm sorry, the log of 1 plus that column, right? That is my logarithmic double time. Log of 1 plus B2, and 69 years. The neat thing about this is I can take this pattern and I can just grow this pattern, you know, all the way down if I wanted to, all the way down to 20%. Check that out. And all you gotta do is click this little plus right here. I want that pattern to hold all the way down to the ooh, I wanted the pattern to hold all the way down to 20. Okay, so you kind of get that. I would have to enter in 1, 2, 3, 4, 5, 6, 7, 8, 9. But anyway, here's the really cool thing about this Google Sheet. I can click on this plus right here, and it will do the same thing all the way down. So my calculations would be that easy, right? I just click on that little plus, and it will multiply by the next cell over. For the rule of 72 doubling time, I'm going to take 72 and divide it by a2, which is right here, which, you know, I would need to finish 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Thank you for being with me on that counting. I probably should have paused it. And I can click this plus, drag it all the way down, and, you know, voila, I have my estimates. Now we can compare our estimates. So for your homework, you had to do this part right here that I've just highlighted, or actually, my bad. You actually only had to do B, cell B. I want you to write cell B and cell D. All right? So yes, I know you could copy this. I hope you'll try to use some type of technology to at least enhance your education. Thank you very much for listening, everyone, and yeah, happy calculating.